Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Now is the third Zoom for visiting lecture program session 2 for mineralogy class A after midterm with visiting lecturer of Dr. Mohammed Abdallah Raswan Atia from NRC Egypt. And now session of question and answer. Student can give the question in the chat of Zoom, and then Dr. Rasban will answer one by one. Okay. Yes. Okay. Kita tadi itu hilang mana?
Hilang.
Yang tadi hilang ya? Di nulis mana?
Kelompoknya Sinta hilang.
Oh, tolong kelompoknya Sinta nulis lagi ya. Tadi belum di ya.
Baik, Bu.
Oke, alhamdulillah. Terima kasih ya. Oke, I will give score for your question, but no score for answer ya. If you are not satisfied, you can easily find the more answer in the Google ya. You can write the question and it will emerge and the answer by AI in the Google ya. I think like that ya. It is okay. Okay, ikan review berarti
Ini search.
Berarti ya.
Mau PPT itu semua.
PPT aja.
PowerPoint.
PPT.
PowerPoint. Tidak sedikit.
Oke. Oke, apa itu? Jadi itu lagi.
Admit ya.
Oke, kedua.
Sekarang.
Oke, dari mana? Rizka dari ini ya. Sekarang yang kedua. Sudah. Oke. Oke, nah. Terus dari mana? Oke. Kita dulu ya. Kita dulu ya. Oke. Dr. Rasban, it has been collected the 3 questions. You will start or still waiting more complete for answer? Yeah, you will wait the complete question by all group.
I'm waiting for
Okay. Yes, you can prepare the answer. Yeah. Although you write the question in the chat, you can also give the question by direct speaking. Yeah, I will give you the additional score. Yeah, if you brief to give the direct speaking to Dr. Raswan. Yeah. Attendant have score 70 and question have the score 70 until 90. If you can speak directly, I will give score 90 and I will divide by 3 ya. Akan saya bagi 3 ya nilainya untuk tugas untuk memberi pertanyaan. Ini keempat ya. Kalau ini kan cuma dibagi 2 ya, 70 kehadiran 70 dan Kehadiran.
tadi.
Iki wis mari ya, Bu ya.
Udah.
Our environment. Oh,
Sik.
sik. Oh, tutup
Rizka
bikin our
Reza.
environment.
Keisha.
Oh, bukan gitu.
Sinta Lutfi belum. Sinta Lutfi belum. Sinta Lutfi
Iya, iya,
enam
oke.
kedua.
Oke loh. Keisha, Wendy,
Keisha
guru ya.
sudah.
Ya kan?
Sinta Lutfi belum.
Shelina.
Nah, ini loh Sinta Lutfi belum.
Oke, sebentar. Oh, ini ada piro yang ke ada piro sing. Ini channel. We like to ikut wiki sini ya kalian. Salsabila Keila iki sing sebelum berikutnya ya.
Iya, saya kira sih sebelum aja.
Oh, Keisha tadi itu
Iya lah yang
baikan semen. Iki nomor 1. Iki apa iki golongane Rizka Reza. Mari ngono. Iso apa?
Sebelum
Kaila. Mari
Keisha.
ngono Keisha. Iki Sinta.
Iya.
Oh iya iya. Terus Salsabila.
Loh, Salsabila kira
Wis ya. Oke. Ini. Berarti iki ngulang lagi ngono iki ya.
Ngulang.
Oh iya. Oke.
Bahwa yang ngilang Keisha ngulang.
Iya.
Si di admit tuh. Di admit. Dia pencet.
Iki double.
Ditutup.
Ya nek
Ada lagi kayak. Coba habis lagi nih.
Florencia ya.
Iya, baru.
Ya. Florencia.
Ya. Pas satu kelompok.
Kurang satu kelompok ya. 1, 2, 3, 4, 5. Ya, remain one group ya. Remain one group to give the question. Granit apakah baik kita terima? Baik. Oh, good afternoon sih, baby. Kayak gitu. It is not good afternoon ya, but good morning. Good afternoon itu lah ya. Setelah apa? Setelah duhur ya, kalau good afternoon.
Masih good.
Kita orang nabi. Ya. Iya.
Oh ya, bawah influensi. Bawah.
Di
Ke bawah. Bawah itu.
coba Fatria gitu, Fatria ya. Oke, komplit ya. Oke, next. Oke.
Pertanyaan awal.
Okay, Dr. Rasman.
Okay.
The question have been complete. 6
Okay.
group have given the question to you.
Okay. Bismillah ar-Rahman ar-Rahim. I will begin with the first question in the screen. The question is, this is good. Why can the relationship between the addition of rock minerals and improvement in physical chemical properties of cement be considered causal? And how does the study rule out the possibility of these exchanges? These exchanges are influenced by other uncontrolled variables. In addition to cement, whether additives or substitutions as the replacement, can it change the behavior of the properties of the cement paste or cement, mortar cement or concrete cement? Regarding the rock minerals, such as granite, marble, basalt, some of these rocks or some of these rock minerals are active or have active sites, what we call the eight pozzolanic, and some others are non-pozzolanic. For pozzolanic rocks like scoria, like diatomaceous, like burned clay or yes, burned clay or burned shell. All these minerals or all these rocks have an activity to react with calcium hydroxide or portlandite that liberated from the reaction of cement with water. So this type of rocks or this type of minerals can enhance or improvement the physico-mechanical properties of cement. While other rock minerals like marble or granites, these minerals exhibit or not exhibit an activity toward or a cementitious behavior or cementitious properties. So their addition maybe enhance some properties of the concrete or cement, maybe like workability, maybe setting time. Also at few additions, maybe 5% to 10%, even as a cement replacement. But more than 10% maybe decrease the properties of the physico-mechanical properties of the cement. For non-pozzolanic materials like marble and granite, as we said, the effect of these minerals gain its effect or its products from its finance or its filling finance, which make a filling as a filling material for the pores or the voids between the cement grains. The change of the relationship are causal, and sometimes other uncontrolled variables like roughness, grain size, I think like grain size or roughness, maybe it's unvariable materials. This is the first question. The second question, yes. We are from group 2, consistent of yes. Okay, this is good. Good, this is good. I can see it. Good. The first part of the second question, okay. Why does marble and granite improve durability via pore filling effect while triggering a significant drop in mechanical strength? Does this suggest an inevitable trade-off between concrete durability and strength? Yes. And why does concrete that is cast and cured at a very high temperature initially show incredible high first day strength, but ultimately results in a much, okay, but ultimately results in a much lower 28 days compressive stress compared to
Anak-anak
concrete
sisi kabeh, Bib.
yes. Regarding the first part of this question, marble and granite improve durability, as we say, or as we answered in the first question, during the pore filling. Pore filling, the pore in any cementitious product like concrete is a very important part in the concrete. Why? Because the durability of the cement product, as we say, cement product, are affected by the presence of pores. Is the product has a high percent of pores or low percent of pores, the amount of pore, the increase in pore may be a weak point in the concrete product, because during the porosity or during the pore or during the voids in the cement product, the harmful materials like sulfate, like any other attack media, can enter during the pore. So when the addition material like marble and granite reduce the pore filling or reduce the pores of the cement product, the durability will be enhanced. Durability will be enhanced. But, this is question number 3. Yes, I think. Why can a cement exhibit excellent performance in laboratory tests, including setting time, compressive strength, and soundness, yet still experience unexpected deterioration or performance loss under field conditions? And how do environmental factors interact with the hydration product to influence its long-term behavior? Okay, this is a good question, really. The first part, in laboratory, as we know all, is a controlled condition. Controlled condition means temperature is controlled, air is controlled, humidity is controlled, and even the human or the workers or the human or the technicians are controlled. So all these properties like setting type, compressive strength, soundness are very controlled and exhibit excellent performance as the standard specifications tell us. While in the field, all these conditions are not controlled or under control, or not under control. Sorry, why? The air is you cannot control the air in the field, in the open field. The humidity cannot be controlled. Sunrise or the sun ray cannot be controlled. All these factors maybe deviate the performance of the cement between the laboratory and the field condition. The environmental effect, maybe that like carbonation can be reduce the long-term behavior of the cement. Maybe drying of the water cementation, drying the moisture content of the concrete, maybe reduce the long-term behavior. And other factors like the attack, the initial attack, or the fast attack, or some deterioration effect like sulfate and chloride. I think this is the answer of this question. Question number 3. Question number 4. So two parts. Yes. Why does the increase in curing temperature need to be strictly noted as providing no drying? And why, if the concrete dries prematurely due to hot weather, can the cement hydration process no longer proceed effectively even after water is applied late? Yes. This is yes, good question, really. But logically, the hydration of semen depend on what? Depend on presence of water or presence of moisture. So imagine after mixing with water, I raise the temperature. So the amount of moisture or the amount of water in the mix are evaporated. So how can the hydration progress without enough water? So the drying make like a retardant. The drying of moisture or drying of water make a retardant. No water. You disturbance the water cement ratio by drying. So the hydration not proceed like you need. The second part, why does cement with high finance like such as 5,485 as shown in the table, which produce very high early compressive strength, yes, like SIM or type 3, make concrete microstructure for far more vulnerable to chemical attack from the environment, such as yes. High strength or rapid or like sim type, I think sim type 3, yes. Early strengthening or cement early strengthening. The high finance of the cement. What mean high finance of the cement, and what is the relation to the compressive strength or early progressive in compressive strength? The high finance mean nearly all particles or grains of cement are subjected to the water. So if the cement with high finance or high surface area, all this surface area are attracted or attacked by the water or the water cement ratio. And if all grains are hydrated or if grains are react with the water in the first initially, this means that no voids are found, or nearly no voids or no pores are found. And if no pore are found in the hydrated product or hydrated cement, so no chance for sulfate and chloride to penetrate in the future. So the high finance decrease the pore size and the amount of pores. So reduce the chance or decrease the chance to any vulnerable attack to such as sulfate and chloride to penetrate in the future. Increase in curing temperatures. I told you the increase in curing temperature will increase the hydration, but no drying. No drying mean you lose some water. You lose some water or some moisture. So water cement ratio is distorted or changing. Water cement ratio is changed by drying. So you decrease the moisture, which is the very important column in the hydration of cement. I think this is the answer what I have for this question. Question number 5. All questions, 2 parts. Good. We would like to ask, the granite waste used in the study has more angular and rough particles compared to natural sand. Okay. Why do these characteristics reduce the workability of the concrete mixture, even if the water to cement ratio remains the same? Good. What first we should ask ourselves, what's the main of workability? Workability mean the interaction or the flow, the easy flowing of any mix. of the easy flow of any mix. So the easy flow or the flowing of the concrete mix are affected by several factors like amount of water. If we decrease the amount of water, the workability or the flowing will be reduced. Okay. Second parameter, the roughness. Why roughness? Roughness meaning angular part. For example, if you have a mixture of angular and rounded between your hands, make or put some materials angular and some material rounded or polished between your hand, and try to move these materials between your hands. What do you feel, or what will you feel? You will feel that the material of rounded or polished between your hands will move quickly, very easy. But for angular material will make a friction or a resistance between the material and between your hands. This is what the granite waste do in the workability, reduce the flow. Workability mean flow. So the angular or the roughness reduce the flow of the material, so they reduce the workability. So what can I how can I increase the workability in this case? In this case, we make admixtures which increase the workability without increase the water in the mixture. The second part, the last part of this question, is a decrease in workability mainly caused by increased interparticle friction, or are there other interaction between rough granite surface and cement? Yes, interparticle friction. One of them is the roughness. The roughness affects the interparticle friction. If there is no roughness, the interparticle friction nearly zero or low amount of interparticle friction. Must be interparticle friction. There must be interparticle friction in the concrete mix, but that friction may be low, may be high, may be medium, according to several factors like angularity or the roughness of the additive materials like granite. The last question. Next question. Question number 6. Also 2 parts. In the first part, in the slide, it's explained that calcium silicate hydrate CSH is the main hydration product responsible for the strength of concrete, whereas calcium hydroxide is also formed in a considerable amount but contributes very little to strength. Yes. Could you explain the mechanism makes CSH the primary contributor to concrete strength compared to calcium hydroxide? Yes. Firstly, the amount of CSH and the amount of CH or polypyrrolidate or calcium hydroxide. How can I calculate or how can I estimate these percents or their proportion by scan electron microscope firstly, and by techniques X-ray diffraction, XRD techniques. All these techniques told us the proportion of these material, of these phases. Okay, you asked about the mechanism. If you mean chemical or chemical reaction, or what do you mean by explain the mechanism? Make this is primary contributor. The mechanism can be explained from the equations. I put it in the table. The equation, the equation tell us 3 mole of C3S and 3 mole and 2 mole of C2S react with 6 mole of water, and the second or C2S 4 mole of water, and the produced or the product 3 mole of CSH and 3 mole and 1 mole of calcium hydroxide. So the amount for CSH is more than the amount of CH. Also, the CSH, the crystallinity or the crystal structure of CSH has no crystal structure. It's amorphous. It's amorphous. So we call CSH a taubermorite-like gel. It's like gel or like glue, which is thick the grains with which is thick the grains of like concrete. And during the hydration of C3A, the slide explained the first part. The answer is satisfied for you, or because the mechanism I don't know what you mean by the mechanism of CSH. Do you mean chemical reaction, or do you mean another question or another meaning, Dr. Dotek? Explain the mechanism. What do you mean by mechanism? Does it mean the chemical reaction, or does it mean the amount of these two phases? Because calcium hydroxide also contribute to strength, but contribute to strength by what? By reaction with another material like pozzolanic materials. This is the second advantage. The second advantage of calcium hydroxide. Second advantage, the first one is protect the reinforcer concrete, as we told in the presentation, by alkaline medium. And the second, by reaction of calcium hydroxide with a pozzolanic material. So calcium hydroxide also contribute to strength gain. If you add a pozzolanic material to the cement, the pozzolanic material don't react with water. React with what? React with calcium hydroxide that is liberating from the hydration. So if there is a calcium hydroxide and there is a pozzolanic material, more strength will be produced. The second part of this question, I will return to the first part, but the second part, the hydration of C3A explains that ectringite can transform into monosulfoaluminate once gypsum is depleted. Why does this transformation affect the properties of long-term durability? I think I noted this this part during the presentation, but I will repeat it again. During the hydration of C3A, the hydration of C3A takes through two steps. First step, C3A reacts with sulfate. Sulfate from what? Sulfate, the source of it is gypsum. Once the first source of sulfate in cement is a gypsum. So C3A reacts with gypsum or sulfate, especially sulfate, plus water, and produce what? Produce ettringite. Ettringite is this phase is a very harmful phase, but if it is produced in the early stage when the paste is plastic, not hardening, there is no harmful or no worry from the ettringite produced in the early stage. Okay, after ettringite produced and there is excess of C3A, still presence of the cement, but there is no sulfate. There is no sulfate. What happened? C3A or ettringite will react with C3A and gypsum. Found no gypsum. C3A will react with ettringite and transform it from ettringite to what? To monosulfoaluminate. Okay. The problem after that, if the structure, the concrete structure is put in a media with a source, another source of sulfate, like seawater. If we build a bridge in seawater or any structure in seawater or in a soil rich in sulfate, monosulfoaluminate phase will react again with another source of sulfate and produce what? Produce ettringite, the second in the second run, but the etrangite, the second etrangite hair are produced when the concrete is hardening. This is the problem. This is the catastrophe. Why? Because when the concrete is hardening or cement is hardening and etrangite is produced, etrangite has in its structure 32 mole of water. Do you imagine 32 mole of water? This water expansive can expansive in the cement or in the concrete after hardening, and this can make a cracks for the concrete and increase the porosity or increase the variability for penetration of other deterioration parameters like sulfate, like chloride in the seawater, especially in seawater. Dr. Tutik, I have finished the answer of your questions.
Okay,
Anyone of your students
Sudah ya.
need another question, or my answer is not
Sudah ya.
funny for them?
Okay, sudah ya.
Sudah.
So I'm sorry, the time remain 1 minute, point 27 second. So your answer must be ended. Okay, sudah ya. Okay, thank you very much for Dr. Muhammad Abdallah Raswan Atia with the excellent presentation today, and also the seriosity in the answer. Yeah, so the many explanation. I think thank you very much for sharing your knowledge and your experience in the research. To my students, I pray Allah will repay you with more blessing that you give us. Ya, rasakan ya kesungguhannya yang begitu besar, dan kita saya doakan ada kelimpahan dari Allah untuk membalasnya gitu ya. Ya memang itu yang saya sukai dari orang-orang Mesir ini ya. Oke, juga publikasinya bagus ya Dr. Aswan ini. I think no time for for taking picture together ya. Masih less than 1 minute sih. Gak usah ya.